Alright, I got a special one for Rochelle and Grant. This was based on the problem that Grant ran into on his Khan Academy SAT prep. The problem he saw was this equation is true for all x where a and b are constants. Sorry, that should be just a, not an. Where a and b are constants, what is the value of ab? Or said another way, what is the product of ab? Okay, so we have this we have a binomial trinomial on the left hand side right here, and then we have a standard form quadratic that's been expanded on the right here. So the first thing that in fact, I think when you guys showed this to me, the first thing I thought of was to try to expand this guy on the left, and that is the right way to go about it. In fact, if you recall, I think I'd miswritten down one of the signs, and that kind of threw us off. So I've gone back, I've done it correctly. If you guys want to go through this, you can. I showed all my work just in case you had any questions. Nothing more than just multiplying our quadrants, or all the cells together here. 5x squared times ax gives you 5ax cubed, right? Now you just take these 6 terms and the resulting squares here, and then of course we're combining like terms. So I obviously just have one cubed term, and I just have one constant term, but I have 2x squared terms, so those get combined, and I have 2x terms as well, so we combine those. All right, we follow my little arrow down over here, and now we're into the crux of the problem here. All right, so this is the cleaned up version, expanded version of what we saw up here on the left, right? Now at this point, this is what I talk about when I say this is a recognition problem. Notice, the terms here on the left match up with these terms on the right, right? So my constant, 12, that's the same there. All right, now look at this. This is interesting. I have a 5ax cubed up front here. Now remember, let's not forget what we're trying to do. We're trying to figure out what a and b are, right? That's what we're trying to do here. What we effectively have are a system of equations. Check this out. If I look at my x cubed term on the left, and I look at my x cubed term on the right, the most important thing to recognize about this problem is what we can deduce because the equation is true for all x. That basically means that what's on the left side is equivalent to what's on the right side. You can put any value x that you want in here, and these two equations will give you the exact same result. Said another way, they are the same equation, right? And that gives us the insight to figure out, all right, well, if they're the same equation, then that means they must have the same coefficients in front of each of the terms, in front of each of your x values, right? So that means that the x cubed term on the right has to equal the x cubed term on the left. Well, if the x cubed term on the right is 20x cubed, then what must the term on the left be? Well, it must also be 20x cubed, except we don't have a 20 there. We have a 5a. Okay, well, we can solve that. 5a equals 20, right? Therefore, a equals 4, right? That's the only way. There's only one value a that will make this coefficient 20, and that value is 4. Okay, so now we've already solved for the value of a. All we need to do now is solve for the value of b, and there are a few different ways we can do it. You can come over here to your x term, and you can say, okay, well, if the value of a is 4, well, 4 times 4, that's 16. 16 minus 3b. Okay, so now we have 16 minus 3b. And let's look at the right-hand side of our equation. What's the coefficient that we have in front of x over here? It's a negative 2. All right, well, that's easy enough. Negative 2. All right, so we need to get a negative 2 in front of this x. So what value b gives us a negative 2? Well, 16 minus 3b, you can go through and solve it algebraically, or I can just tell you 3 times 6, that gives us 18. 16 minus 18, that gives us the negative 2. Hey, look at that. So b, we just solved for b. b equals 6. All right, cool. So now I know what my a is. My a is 4, and my b is 6. So you guys can tell me what is 4 times 6. There you go. 24. Now, I said that you could have solved this a bunch of different ways, and that is true. The easiest way, though, is recognizing that you have a simple 5a equals 20, and then plug in your value of a. And I could have plugged in 4 over here, right? Because look at this, the x squared term, I have 15 minus ab. I just need to get that equal to negative 9, right? So I could have set this up to say 15 minus 4b equals negative 9. And we could have also solved b and gotten 6 that way too. So a bunch of different ways to do it. But ultimately, this problem comes down to noticing, number one, being able to expand it correctly, right? But then also understanding what they mean when they say for all x, just basically is another way of saying, a fancy way of saying that these two equations are equal, right? And then the final insight was to say, okay, well, this is just a system of equations where I'm trying to solve for the coefficients in front of each of these x's, right? After I recognize that they're equal. All right, so sorry I couldn't explain this one to you in person. I'm sure if you have any questions, Grant, that Rochelle can help you out now at this point here. But yeah, again, these questions, right? I mean, like, this probably is not the question that determines whether you're getting an 11 or a 1200. This is probably, are you getting a 14 or a 1500? Uh, I I don't know what I'm saying. I don't even know how the SAT scores work anymore. So, any rate, I hope you all have a wonderful day and weekend, and I will see you guys around.